Okay, good afternoon. My name is Vincent Hargadan. I'm from UCD Engineering, and what I'm going to talk to you about over the next 10 minutes is how we in UCD Engineering are developing what we call the AAA Manufacturing and Supply Chain Professional. So we're going to talk about, well, what is the AAA supply chain? Maybe some of you who watched television in the 1980s might remember a veterinary product that was also called AAA. We don't believe there's any link between the motivation for the AAA supply chain from Howley in Stanford and an Irish veterinary product. And then the next few points are really looking at, if we take a AAA supply chain, where in UCD and where in industry are we working, where we are working with to develop these type of professionals. And what we're going to talk about first of all is for people who are based in industry, how can we develop what's called the business savvy engineer, and we do that primarily through the MEM program, but also with our undergraduates, postgraduates, PhD students and industry professionals who have specific skill gaps. We've developed a learning factory in smart precision engineering. So I'll explain what the concept of a learning factory in both the university and the industry environment is. And also, we'd love to hear of other opportunities where we can engage with industry, whether it's your part-time employees or whether it's your general skills that need improvement. So the AAA supply chain, this is Howley. He's an academic. We're probably unfair to call him just an academic. He's a supply chain guru based in Stanford. And he came up with this idea of a AAA supply chain. So his argument was that supply chains should be agile, adaptable, and aligned. So in other words, they should be agile, they should be nimble, they should be able to adjust to changing consumer demand. The adaptive idea is more medium term. They should be able to evolve as customer demand evolves, trends evolve. And they should be aligned. So not only between the partners in the supply chain, but also aligned with customer needs. So if your supply chains have to conform to this idea of AAA, well then surely your people in your supply chain should also conform to this idea of being agile, adaptable and aligned. So the first area I'm going to mention where we at UCD Engineering are trying to develop AAA supply chain professionals is for engineers and scientists who are already based in industry. And they're probably around the 5 to 7 year experience mark. Very good at the technical side of things, but are now starting to make management business decisions. But maybe they just did one course in business in a mechanical engineering degree, and now they're talking to finance directors, HR directors, marketing directors, and they're hearing a language that they're not really familiar with, not comfortable with. How do they bridge that divide between their technical expertise that they're very good at, but no longer necessarily needing to the same depth? They can solve a structural problem to 10 places of decimals, but that doesn't mean that they're very good at the industrial relations side of things. So how can we develop that? So the international context is a couple of studies. The Financial Times talked about developing business savvy engineers, and that the MEM is becoming the interdisciplinary degree, taking technology professionals and giving them the business knowledge they need to progress to senior management in engineering companies. Wall Street Journal commissioned a piece of research a few years ago to look at, well, who actually are the CEOs? What's the background of the CEOs? And I think they were surprised at the percentage of the companies they surveyed. Over 60% of companies they surveyed, their CEOs actually had a technical background, not an MBA. So they're arguing, move over the MBAs, here come the engineers. So what we're trying to do in UCD Engineering through our MEM program is basically bridge that gap between the technical knowledge that people have from their undergraduate qualification and complement that with the latest business thinking so they'll become senior management and senior leaders in technology enterprises. So it's our flagship program. It's been around since 1967. Some of you may know people who have been through it as the MIE. It was called the MIE for about 35 years, in the mid-90s, early 2000s. Industrial engineering had a certain maybe negative connotation in Ireland, even though the content had evolved, so we renamed it the MEM to reflect what was happening internationally. With nearly 700 graduates, many of them have gone on to be operations directors, CEOs of major companies. And the way we have designed this is it's a 2-year part-time program. So these people have 5 to 7 years industry experience. They come to us on Friday afternoons, Saturday mornings. So it's an intensive, the word was used earlier, boot camp over 2 academic years. They have to have some sort of technical background, whether it's engineering or science, or computer science or software engineering, or even we get some architecture professionals coming back to us. The real idea is we look at their technical and analytical skills, and on top of that then we add the broad business and management expertise. What our real goal is that we want to form the future engineering leaders for global corporations, both within Ireland and internationally. Now the major themes, it's heavily operations focused. Okay, so operations supply chain forms a core theme of what we're trying to do in terms of project management, quality, business system design. Some of the other major themes there are capturing what's happening within industry. So data analytics, big data is a buzzword, a key trend that's emerged over the last few years. So we focus on some of the techniques for decision making, for business decision making around quantitative methods and decision analysis. We do core business modules in terms of cost analysis, budgeting, product pricing. We've got the strategy modules, and then we've got the people behaviour. So now I mentioned in the previous question that the big challenge for a lot of engineers is actually managing people or working with people. They're really good at the numbers. And when our students come in and they see they're doing behaviour leadership and change and managing human resources and negotiations management, they go, what's this woolly stuff for me? But actually, they're surprised by the end of those courses, the amount they get out of it, because the learning has been so great for them. They probably, on reflection, find those maybe the most informative type of courses that they actually take. So over the 2 years, it's a fairly intense. Students come in around 2:30 on Fridays. They take 2 classes on Friday afternoons, 2 on Saturday mornings. Although it's a 12-week semester, so 12 weeks in autumn, 12 weeks in spring, and same again the following year. And everybody more or less gets through. They're highly motivated, even though they've got maybe their early 30s, busy jobs, and maybe starting young families. And the way we structure in terms of the teaching team, the core team within engineering, obviously. We use some business school colleagues, and also about a third of our colleagues are leading industry practitioners, so they're bringing the industry flavour as well, particularly around the area of, let's say, quality management, Lean Six Sigma, so the latest thinking, data analytics, big data. Give you an example of some of the current programme participants. We're sector agnostic, if you want to refer it. So we get ICT companies, medtech, pharma, traditional engineering companies, engineering services. We get representatives from utilities, public sector. So it's a broad mix of companies and sectors. But where the real learning is, it's in the classroom environment. It's talking among your peers from different sectors about problems that you're encountering and how you apply the learning across multiple sectors. The second area where we're looking at developing this AAA professional is more internal with our own undergraduate students, ready to launch them into industry in graduate entry positions. Although we're working also with industry partners in this area as well. It's the idea of a learning factory. The principle of the learning factory is really based around this Confucius statement: I see, I forget, I hear, I remember, I do, I understand. So within 2 weeks, if you simulate the real experience and do the real thing, you'll remember 90% of what we say and do. And the idea of the learning factory is to provide a real learning environment, albeit in a safe environment, to do real production. So make real products, encounter in a batch production environment, to encounter all the issues that you would within a manufacturing facility. And it's kind of, the idea of learning factories come from the way medical students are taught. See one, do one, teach one. So if you can observe something, you can do it, and then you can teach somebody else, well then you become the expert. Learning factories are scattered around Europe, both within academic universities and also in industry. And they each focus on a different theme. So there's a very good one in the Technical University of Darmstadt, where we visited several times. They focus on lean systems. There's other ones that focus on logistics, or those focused on energy systems. What we focus in UCD is what we've called smart precision engineering. So the precision engineering side of things is we take students, it's about integrated learning. They go from designing a product on paper to CAD, selecting materials, building the system, measuring the parts in a batch environment, batch production environment. It's not just a one-off. So that's the precision manufacturing. But where the smart aspect comes in is the machines are interconnected to the cloud. So we're getting real-time data coming off the machines that then can be used for predictive analytics to monitor the condition of the machines. And this is where we're actually starting to work with industry as well. They're really interested in this kind of idea where actually we can use data analytics to predict failures, to observe the real state of the machine as opposed to kind of a technician hearing or noticing a strange smell or a slight shake, and he knows that, he or she knows that the machine needs to be repaired. So the way it works is it's all interconnected, and we're using data analytics, and we're using the Insight Centre for Data Analytics to actually conduct the machine learning, the statistical analysis, and the behavioural analysis of the equipment. So, as well as actually learning the manufacturing, process, production skills, the students are being exposed to data analytics approaches that can be used. So, with the idea of the Internet of Things, smart production. So, this is where we're starting to. We've put 80 students through it so far this year. We launched it just last September. We put 80 undergraduate students through it. We're putting our masters, PhD students through it. And we're also starting to work with industry to come in and use this as a demonstrator that they can then go to their own manufacturing facilities and see how you need to create this infrastructure and use the data analytics to monitor your systems more effectively. The final way in which we're looking at building this idea of the AAA supply chain professional is more outward looking. The first point is specifically with SMEs. We're looking at launching an Interreg funded program to build capacity for advanced manufacturing. Interreg is very metric driven. I don't know if anybody has been involved in any Interreg programs. It's not abstract academic research. It's very much skills development, a number of SMEs engaged. So what we're looking for, there's no cost to the SMEs. This will be fully funded in terms of kind of vouchers, where we would conduct a needs assessment on skills with individual SMEs and then partner them with the right partner around Europe that are part of the consortium to build skills needed for advanced manufacturing. Over the next couple of months, we're going to be hopefully submitting a proposal to Science Foundation Ireland to build a centre in manufacturing, and obviously that is significant industry involvement. On a wider European scale, we're going to be involved in what's called a knowledge and innovation community. So there's a lot of three-letter acronyms in the European community. So the EIT is the European Institute for Innovation and Training. They have KICs, Knowledge and Innovation Communities, and we will be setting up an RIH, a regional innovation hub between Ireland and the UK in advanced manufacturing. And the KICs are again very much skills based. They're not research based. So again, it's providing skills training to undergraduates, masters, PhD and industry professionals in advanced manufacturing. And obviously the last one then is the one that I'm directly responsible for, where you have industry professionals that need to bridge that divide between their technical knowledge and the business skills needed for their positions, is the Master of Engineering Management. Okay, so anybody wants to have any follow-up conversation with me, I'll be around for probably another hour or so. It's my email address, and we'll be at stand 76 until about 5 o'clock. And we've got some brochures on the various programs if anybody wants to pick one up. Okay, thank you very much.